Hi, my name is Thomas Maurer. I'm a cloud advocate working at Microsoft. And in today's video, we're going to have a look at Windows containers. And so we will have a little bit of an overview. Why would you use containers? A little bit of an overview how they technically work and the differences between Windows containers and Hyper-V containers. And then later on, we're going to have a look how you can use Windows Admin Center to basically containerize your existing applications and then upload them to a Azure Container registry and deploy them, for example, on a Kubernetes cluster in Azure using AKS. So stay tuned. Before we're going to have a look how we can actually use Windows containers, I want to quickly highlight why we actually want to use containers in our environment. For that, we're going a little bit back in time. Like in the beginning of IT and data centers, we basically start to use servers and then we installed operating systems on these servers and we installed the applications on that specific operating system. A while back, we then used hardware virtualization, which allowed us to run multiple servers on the same physical hardware, which allowed us basically to be more efficient and also run different operating systems and different workloads next to each other. However, there are a couple of challenges when it comes to containers. For example, how do you declaratively compose a virtual machine? Or how do we make sure when you move applications between different environments such as development, test, or production, that they stay consistent, right? We all have done that. We all have manually installed servers, installed the operating systems, did the base settings, but often they're not very consistent, right? And then we end up in an environment where we basically have to say, hey, but it worked on my machine, but we realize that the production environment, for example, has a different configuration than our test environment. And that is where containers can help us with all of that. So first of all, containers help us to be more agile and ship our applications faster because they are smaller, they have a less footprint, so it's easy for us to move them. They're also more portable, so we can easily move them between different environments or also different infrastructures. And since they take less resources, they allow us to be more efficient with our hardware resources because they don't have the overhead of the complete operating system. Since containers can share a kernel and parts of the operating system, we don't get that additional overhead. And this also allows us to rapidly scale applications up and down based on the demand. Now, what are we trying with Windows containers, or why would we actually use Windows containers? So first of all, obviously to modernize our applications and then pack them into containers to basically use our, for example, development pipeline to ship them faster, to do changes faster, and then run them on any infrastructure we want them to run, right? We can containerize the application in our data center, and if we want to move them to the cloud, we can just basically move these containers to a cloud service where we can run that container. So I don't want to spend too much time on what is a container, but like for everyone that we have some basics to understand how a container works and what it is and how I can actually run it on Windows. So I talked a little bit about the benefits of containers. And if we have a look at a server, for example, what we usually have is, as I mentioned, we have hardware, we install an operating system, then we have a kernel and we have different applications and services. Now, if we have a closer look at this, that means we have applications and services running in the user space, and then we have the kernel space where we have our kernel. Now, when it comes to containers, what we can do is instead of just sharing the hardware, we can also share the kernel space. So in this picture here, we can see here we have two containers, which basically all share the same kernel resources. So I can pack different applications and services in one container and a different application in another container. And they can run next to each other, side by side, and they basically use the same resources. Now, to show you this, I want to quickly show you a demo about Windows Server containers. So here I am on a Windows Server 2019 host. I already installed the container feature, I installed Docker, and I already downloaded a couple of container images. Now, to show you here quickly, right now I'm on the container host 01. And if I run Docker images, you can see here I already downloaded a couple of container images. Like for example, this one here, this is the server core image with tag 1809, which is also the version of that specific container. And then you can also see the size of that specific container here as well. You can see here also the nano server, which is significantly smaller image than the server core. And we'll talk a little bit about that later. Now to run a container, we just type docker run. And in our case now, we use IT for interactive terminal. And then we will specify the container image we want to run. In our case, we're using the server core image, and we will tag it with the specific version. And now let's run that container. Now, because I used the interactive mode, I'm now in the container itself. So if I type host name, I will see here I have now a random generated number as the host name. And you see here I also have a file system. And you also realized how fast I started that container. It took a couple of seconds, if not milliseconds, to start that container. I can also run PowerShell in that server core container. So let me write get process and see what processes are running in that container. And you can see here, it's a very small amount of processes running in that specific container. Now let's compare that to what is running on the container host itself. So if I type host name, you can see here again, this is my container host 01. And if I do get process, you can see here I have much more processes running on that specific container host. I can now have a look at a specific process. So let's have a look at that PowerShell process here. And so obviously if I go here and type get process and then enter the ID of that process, you will see here that obviously that process is running on that machine or in that container. Now let's move back to the container host and see if we can find the same process with the same ID also on the container host. And as you can see, yes, we can. So the host can see the processes running inside the container. Now let's have a look at some of the processes which are running on the container host itself. Now here I have some other PowerShell processes running. So let's take this specific PowerShell process and let's see if we can find that process within the container. So now you can see the container can't see the processes running on the host, but the host can see the processes within the container. So that is where we basically have this isolation. If you want to have more isolation, we also offer something called Hyper-V containers, which basically completely isolate using Hyper-V technology. When I go back to the host and I type docker ps, you can see here I have a container running. This lists all my running containers. And if I go back to my container and I close that container, and I go back to the host and I do another docker ps, you can see that this container is now gone, right? So you have a quick overview about what containers are actually running on that machine. So as you saw, there are a couple of benefits to containers, right? Not only do they consume less resources, they also boot very fast. And so why is that? So if we have a look at a boot from a traditional server, which can run in a virtual machine or on a physical machine, it's basically we have a couple of steps. We need to power it on. You have the BIOS which runs the post and then starts the OS loader. And then we have the OS loader which starts, we have the kernel which starts. And then if you look at container, that really doesn't need all these steps, right? It can just start a new session and then basically start processes like Explorer, for example. And so that is why it's extremely fast to start a new container. As already mentioned, there's also significantly lower overhead. So if I have a look at a server, for example, here, this server without running any containers uses 2.8 gigabyte of memory. Now, if I start a container, you will see this one container takes 200 megabytes. So I'm running now 3 gigabytes of memory. And if I look at it, if I start 5 of these containers, I'm now consuming 3.4 gigabytes in size in memory. And you can see that this is obviously a very small amount of memory I'm using. It obviously also depends what I'm running in these containers. But you can see here that I basically have only one time the operating system overhead of 2.8 gigabytes. And then the rest of the applications I can basically only use what I need. So let's have a look how we actually work with containers. And if we want to work with containers, we need to understand how we actually build one of these container images, right? You have seen that I showed you 3 different container images, which are basically base container images. But if I want to install an application, what I usually do is I don't go out and then start a container and then install the application in that container like I would probably do with a virtual machine. I would first build a container image in a declarative way. And for that, I want to explain you a couple of steps how that works. So with a usual application, we have an OS instance, and then we would install all the dependencies. We would then install the application and then do the configuration tasks for that application, right? That is how we would actually go out and build this or set this up. Now, in the world of containers, these are different layers. And so we start with a base container, base operating system image. That can be, and I will talk a little bit about that, can be a Windows image, Windows Server Core, or a Nano Server image. And then the next layer would be our dependencies, like for example, in this case, with .NET Core. Then we add our specific application, and then we add our configuration, for example, with registry keys or some scripts we run in that image. Now, let's have a look first at the base images. We offer 3 base images, and you can see here they are different in size because they're also different for certain use cases. So Nano Server, for example, is for new apps based on .NET Core. It's a very small image, so the overhead is very, very low. Then we also have Server Core, which is designed for your traditional server workloads, and it includes the large .NET framework. That is also why the image is larger. Now, if you have applications which need more Win32 APIs, such as for example, DirectX or Print Server, then we also have a Windows image, which is even larger, but again, offers more compatibility for your application. So you can use one of these 3 images, but we also created a couple of shortcuts for you. So for example, we have the .NET Core image, we have a PowerShell image, or if you, for example, need IIS to run your web application, we already created an IIS application, so you don't need to go out and build all the time a Server Core image with IIS installed. So how do I actually create that container image? I told you that this is usually a declarative way, and I would build a Docker file. And you can see here's an example of a Docker file where I say, hey, what base image I want to use. So in the top, you can see here, I'm using the Server Core LTSC 2016 as a base image. And then I install the .NET framework, I apply patches, I add other parts I need, and I would go on and write all the installation steps basically down, as well as the configuration steps. Now, we want to make this easier for IT pros and developers. And that's where I will show you in a bit the new Windows Admin Center container extension. After we have created a container image, the next step we actually want to do is we want to push this to a container registry. From there, I can then go out and deploy it to other container hosts or to other Kubernetes clusters running on-prem or in Azure or wherever you actually want your container to run. So with that, I want to show you a quick demo now about how you can use Windows Admin Center to create your container images. So here I'm in Windows Admin Center. I'm connected to my container host, and you can see here that I have my container extension installed, and if I click on it, you can see here that currently they're running no containers on that container host, but I already have 3 images. Those are the 3 images I showed you before, right? So this is the server core image, the nano server image here, for example. And if we look at that, we can also see some more information. We can see the version and the size of that image. Now, let's switch here to the application. So this is a IIS web server installed on our App01 machine. And here I have the Tailwind Traders awesome website, which I used all my web design skills to create that website. So that website we want to containerize and move it to other platforms. So what I need to do here is actually create a new container image. And again, I could go out and write that Docker file, or I can use this extension and say, hey, create a new file. I can then say, okay, I want to use an existing Docker file, but for us, we just keep on running in that wizard. So we can select if it's a static website. So I'm going to select static website in this case. I can then give the source path for the website files. So this is the Tailwind Traders website. And I'll select that folder. I can then also add some additional scripts I need to run if I need to install or configure specific settings. And now I give that image a name and also a tag, which in my case I use for versioning. And you can see here, it created a preview of the Docker file for me. So it says, okay, from which base image I want to start and which commands I need to run. Now, if I click on build, this will create my container image. And depending on what you're doing, this will take a couple of seconds or minutes to create that container image. So now we successfully created that container image. And if I do a refresh of Windows Admin Center here, you will see that I now have 4 container images here. One is the TT website with the tag version 1. What I can do now is I can have a look at the information here. I can also see what parent image I used. And I can now go out and run that container image on that container host. So I can say, okay, here, that's the name for that container. And if I want to, I can also use Hyper-V isolation, as I mentioned. I can then do the port mapping. So I'm going to map port 8000 to port 80 and click on run. Now, this will now go up like I did the docker run command and will start up that container. And if I go to containers, I can now see that my TT website is running on that container host with that container image. Now, if I go to a browser, and I'm now browsing to container host port 8000, you will now see that I can access the Tailwind Traders awesome website running inside that container on that specific container host. Now I can also see some more information about that container. So if I'm running container hosts in my environment, I can use the container extension to basically manage that container. I get some overview. I can also see here when I hit the container that there is some network traffic going on, that it uses more memory. I can also find some more details about the configuration of that container. I can also access logs of that container or use the console to access that specific container or the container host itself. Now, what I want to do now is, because I know now that this container is working, I want to push it to our container registry. For that, I just select the container image here and click on push. Now, again, I could go out and change the name of that image if I want to, but I actually now want to just select our Azure Container Registry, which I already created in Azure. Now, this will, thanks to Windows Admin Center, this will allow me to select my subscription and the container registry I created. And now I can push this to my container registry in Azure, and this will upload my image to Azure directly. And again, I can also use another container registry. It doesn't necessarily need to be an Azure Container Registry, but in my case, I use the Azure Container Registry. Now this will take, depending on the image size, obviously, this will take a couple of seconds or minutes to complete. And now you can see here I pushed the image successfully. And if I now switch to the Azure portal and I browse to my container registry, you can see here, here's my container registry. I can then go to repository and you can find here my TT website and here version 1. So now we need to run this container somewhere, right? We can run it on my container host running in my data center. I can use Windows Server, I can use physical hosts or virtual machines, but I can also use my Kubernetes installation, right? And in our case, I want to run it on a Kubernetes cluster in Azure. And for that, we have Azure Kubernetes Service, which is a managed Kubernetes cluster in Azure. So for that, I want to show you how I now can take this Windows container from our container registry and deploy it to AKS. So here I am back in the Azure portal. You can see here my AKS cluster, which I created before. And this one is configured to basically also run Windows containers, not just Linux containers. So for that, I want to have a quick look at the node pool. And if I click on it, you will see that I here have Linux nodes, but also Windows nodes now available. And this allows me to run Windows containers on AKS, on Azure Kubernetes Service in Azure. To deploy an Azure Kubernetes Server or an application on an Azure Kubernetes Service, I need to basically have a YAML file with the configuration. And here I have already created the YAML file. I'm open up Cloud Shell, and with code I can basically have a look at that specific YAML file. And here is the complete configuration of this application. And this is just a one container application, but you can see here the image from our container registry, right? So there's our TT website v1, and this one I want to now deploy to my AKS cluster. So let's close this, and then let's apply that application to our Kubernetes cluster. So we now created the deployment to deploy that service on our Kubernetes cluster. And if we go and get the service, we can basically watch what's going to happen. And you can see here that it's deploying, and we are waiting basically until we get a public IP address assigned for that specific service. After a while, we get the public IP address for that specific service. And if we copy that public IP address and open up a browser, we see here, this is the browser where we still had the container host 01. Now open up a new tab with that specific IP address. I hit enter, and you can see here, here's our Tailwind Traders awesome website running now in a Windows container on Azure Kubernetes Service on Azure. So this is what we just did. We basically took an existing application. In our case, it can be a .NET application or another application. It can also be a Linux-based application in a Windows container. We containerize them. We build our container images, and then we push them to Azure Container Registry. And From there, we can then deploy them on AKS in Azure, or obviously also on other container hosts in your own data centers, or even Docker running on your Windows machine or on your Linux machine, whatever apps you want to run. So if you want to learn more about this, I have a couple of resources for you here. Again, there is much more behind this, but here you have a couple of links, for example, that you can learn about Windows and containers to get started. There's also getting started to basically create your first Windows container and run it on your machine. You don't necessarily need a Windows server to try it out. You can also run it on your Windows 10 machine. Then I have some documentation here about the Azure Container registry documentation, where you can basically get all the steps to basically set this up and have your own registry running in Azure. And then last but not least, we obviously have the Azure Kubernetes Service documentation, so we can find out how I can deploy a Kubernetes cluster in AKS with a Windows node pool, so I can also run Windows containers on top of this. Thank you for watching. I hope you enjoyed that video. If you enjoyed that video, make sure you like the video and don't forget to subscribe to the channel.